Hey, what's going on, guys? CodeMonkey here. In this video we're going to learn how to represent chessboard position as an array of integers and print this to screen to make it kind of more readable and user-friendly using the C programming language. So if you're interested, let's actually start writing some code. So the very first thing to consider, I need to import some system headers here. So I can say include and stdio.h, which is needed in order to be able to use the printf function, which is the basic function in C programming language to output the data to your console. And the next thing to consider, we need just to provide the main driver here, and there is the standard method called int main, where the compiler actually compiler is looking for this sort of main function to as an entry point for executing your code. Let's return 0 because the integer function in C really should return some numeric value. And also let's try to print something to console just to make sure that this stuff compiles and runs. So let's say chess and hexadecimal 88. By the way, the hexadecimal 88 stands for the board representation type that we're supposed to be using within this chess program, so I'll cover this just right at the moment. But first, let me just try to open the terminal in the current working directory right over in here, and by simply typing gcc, which calls the compiler, C compiler, that should be pre-installed on your system obviously, but if you're using IDE, probably you have that installed automatically, and this makefile stuff is happening automatically as well. But I prefer the bare command line stuff, so I can say gcc and then the file name, so chess underscore hexadecimal 88.c and -o to create the object, so the binary executable here, and I call this the same chess underscore hexadecimal 88. Then this double N stands for if this stuff compiles. In this case, I want actually to run this, so chess underscore hexadecimal 88. So this command might vary slightly a bit if you're on Windows, probably saying like gcc.exe and this, like without this dot slash, probably just chess hexadecimal 88.exe and enter. I'm not sure. I haven't been using Windows for about 10 years. I don't know. I will never get back to that as well. So let's try to see what we got here. Okay, we got our string being printed, so we just can add a new line just to pre-print this stuff. So the code compiles and runs, which is absolutely fantastic. So now let's actually try to provide some basic data structures that we're supposed to be working with. And before we actually go on creating our board structure, first I want to define the piece encoding. So piece encoding here, and I will use the C programming language enumerator stuff here. So this enum, and now I can say, so I will be using the letters in order to encode some numbers, and this would be just used to easily reference the pieces, because otherwise, if you know that the white pawn is 1 and like say black pawn is 7, it's way too different. It's hard to remember, so it's better to have some sort of visual representation of your characters. So we'll need an empty square, and then to encode the empty square, then we'll need to encode all the pieces, and then we'll need to encode the of-board square. Okay, so let's go for this. So let's say that empty square would be equal to E. Okay, then we have there is a by the way, yeah, I forget to say that there is a standard notation to represent chess pieces in ASCII characters, and we'll make use of this notation, but instead of using the ASCII characters for like as a string characters, I'll be just using them as the variables as well, which is quite pretty handy, by the way. So we'll start with a white pawn, which is a big which is an uppercase P. So pawn, then knight, and then bishop, and then rook, and then queen and king. And after, so the uppercase letters stand for the white pieces, while the lowercase characters will stand for the black pieces. So the black pawn will be here, so pawn, then knight, then bishop, then rook, then queen, then king. And finally, I want to define this O, which would stand for the offboard square. So quite pretty simple and hope pretty self-explanatory as well. And from now on, I just want to show you one little trick here. So if I can, if I just want to type some pieces here, okay, some pieces, and let's give just some random piece decimal here, and well, let's print the empty square. It would return as a 0 because the empty square refers to the number of 0, you see, like here. And let's have like a white pawn, so this would be 1 respectively, and then we have the knight, this would be 2 respectively, and so on. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 for the offboard square, which is not really that essential to give the particular number. Well, there are systems where the piece encodings are absolutely essential, especially if we're trying to optimize the chess program for the code size. But we're not really going to do this in this series at least, so we can just pick up the most common natural encodings for our pieces. So now let's define our chessboard array basically. So chessboard representation here, and I just create the integer board, and this would be an array of 128 characters. And now it might be slightly bit unclear why exactly we use this number in particular, but as far as I will start kind of drawing the board within the source code, you will understand it way better. And obviously later on we'll create the parseFen function, probably this would have been within the next video, in order to be able to actually initialize the board using the fen string, which would be covered again like probably in the next video. But for now we just need to make sure that our print board function that we're supposed to be creating quite pretty soon works. We need to manually set up our board. So the top left corner of the board stands it would stand for the black pieces. So we start with the black rook, then we'll have a knight, then the bishop, then queen, right, then king, then again the bishop, the knight, and the rook. And I just give it 2 spaces just to visually show the onboard, to distinguish between the onboard and the offboard squares. So here we go in the offboard square, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now we're going for pawns. So we got pawn, pawn, so these are the black pawns, pawn, 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 and then the offboard squares again. Okay, and then we have empty square, empty square, empty, 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 and then this offboard squares. Now we can duplicate this even more, and here we have white pawns standing. So you see, like, it already starts looking as a real chessboard position, believe it or not. So now we have this rook, then the knight, then the bishop, the queen, king, and again the bishop, knight, and the rook, and this offboard stuff. Okay, so okay, and if let's say we just want to print our board array referenced by the index of 0, which means the first element, so this would be the rook. So now let's try to think what number it should output for us. So let's calculate. So 0, 1, 2, 3, 4, 5, 6, 7, 11. Oh my god, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it should print 10 to the console. So, and this 10 would stand for the piece code of the black rook. Okay, give me 2. I'm just wondering why is this happening. Like, hold on, guys. Just this is a bit weird. Board 0. How is this? How is this possible? Just hold on a sec, guys. Okay, I'm sorry. Probably I just forgot to save the file here, so it just was printing the previous output. So yeah, obviously now we have this. The board of 0 would be equal to 10, which is the code for our rook. So hope this is pretty clear. Okay, and the next couple of things to consider. I would like to provide a couple of piece encoding. So let's define the ASCII pieces. Let's just well, just ASCII pieces. Okay, and also Unicode pieces. And you know, like ASCII pieces is just the worldwide standard for representing the chess pieces when you print them, when you print the board to the console. But I also like these Unicode pieces, especially it's incredibly easy to use them on Linux, as I do. So just to print the pieces, so you see the actual pawn, rook, knight, etc., instead of this ladder. So I will show you both cases, so you would be able to choose whatever you like. And if you find a way how to use the Unicode pieces on Windows, and I swear that is possible, just I'm not sure how exactly this is done because I don't have Windows. Please let me know in the commentaries like how exactly that can be done actually. So first let's create this would be the char array, and this would be called I'm sorry, maybe calling this char is not really that right, but I would be calling this because I used to, so just forgive me if I'm doing something wrong, or just point me out that within the commentary. So let's call this ASCII pieces, and this would be a string. So so we want to map this piece encodings to the corresponding ASCII characters. So we want dot for empty square, and you know, like this actually the string is treated to be as an array in C programming language, and we can use indexing within the string to reference the particular character, just like we can reference the element within the array, which is quite pretty nice. So basically the string is yet another array, but it's just an array of characters. But again, like characters is just the way to represent integers and to encode them to ASCII codes. But let's move on. So enough theory, like let's move on. So then we have the white pawn, and then we have the knight, the bishop, the rook, the queen, and the king, and then we have black pawn, knight, rook, okay, knight, rook, sorry, knight, bishop, rook, queen, king, and well, we don't really need this off-board square because we're not supposed to be referencing this, but for now, well, let's actually have this. I'll just get rid of this. I'll leave this just now just to demonstrate you how it kind of works. So I will drop the Unicode pieces for now. I will add them later on after I debug this, the print board function logic, basically. Okay, so here let's define the print board function, basically. So this would be the type of void. The void function in C is the function that doesn't return any value. It can just return, but not without any value. So let's call this print board, and okay, and here we'll provide our main logic. So okay, now we need to loop over the files and ranks. So before doing this, let me explain what is known as files and what is known as rank. So this is the rank 1, this is the rank 2, 3, 4, 5, 6, 7, 8, and this called A file, this called B file, C, A, B, C, D, E, F, G, H, and this is it. So first we will be looping over the ranks. So starting from this starting from this rank and then going down, 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 down again and again. And then we would be looping over our files. So loop over board ranks, and I can say for creating the variable rank, so rank equals to 0, rank is less than 16, so up to 15 iterations here, so less than 8, I'm sorry, so 1 2 3 4 5 6 7 8, so 8 times. And then we want to increment our rank, and then we want to loop over our files, so create another variable like int file, and file would be less than 16 in this case, and again the same like file plus plus. So incremented the file, so plus plus is the shortcut for saying like file equals file plus 1. So like say file equals file plus 1. So just to bear in mind like what this plus plus stands for. This is the standard C programming language shortcut. And now we need to initialize the square variable. So let's say init square, and the square would be the type of integer. So int square would be equal to, and here a little math is involved. So we need to multiply our rank by 16 and add the file. And this is this kind of expression is used in order to convert this files and ranks into a particular square index. So this square just will stand for the particular board array index. So hope that's kind of clear. And first let's actually try simply to print this square. So square, and this is the integer, so the decimal stuff here. And now I'm supposed to see, okay, so also I want to call the print board function here, so I can say print board, okay. And now it's supposed to see indexes like from 0, 1, 2, 3, 4, and up to 127, which is the very last index within this 128 length board array. So let's actually save this stuff and try to run this again. Okay, so probably I forgot a semicolon somewhere here. Okay, C programming language doesn't forgive you missing semicolons, so just to make sure you need to use them. Okay, print f function board undefined reference. Oh, not print. That's the Python legacy. Yeah, sure, it's called print f, not print. Okay, so just what I've been talking about. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. Okay, so this is already pretty nice, but every time we go to a new rank, it would be nice to print a new line. So let's say print new line every time new rank is encountered. Okay, so I can simply say printf, and the very new line, that's kind of it, nothing much. So just compile and run this again, and you see like it already looks like something that we have presented here. So you see like we have the 0, 1, 2, 3, 4 and up to. But now the problem is that we don't really need all this sort of squares, because only the 8 squares on the left are valid squares, while the 8 squares on the right are of board squares, which we don't really want to put the pieces onto. And again, okay, so I will now show you the main trick regarding the hexadecimal 88 system and why is this so popular, why is this so cool basically. But probably I need to add up to 8 up to 8 O's in order to represent the specific index. Or okay, just hold on a sec, guys. Just I need to think a little bit how better to do this. Okay, it seems like I just said a nonsense now, so let's drop it as it kind of was here. Okay, so at the moment we do have our indexes being printed, but obviously we have already the board array being initialized to some sort of a particular values with the encoded pieces. So the next step to consider would like to see actually these values. So instead of printing this square, let's reference our board array indexed by the square, because as I have already been mentioning, this square stands for the index of the board array. So now we should see some values that correspond to the chess pieces. You see, like, we have this zeros for the empty squares, right? We have this 13s for off-board squares, and we have these different values for our pieces. And now the very last thing left here is actually, you know, like, it's incredibly difficult to remember that this is the black pawn and this is the white white bishop, right? And this is the white rook and this is the black rook. It's incredibly hard. So it would be way easier to represent these numbers with some sort of a user-friendly characters. And let's now, as far as we have this board indexed by the square returns us this piece encoding, and now we will use this sort of a piece encoding as an index to index this ASCII pieces array. So let's say we have the index of 10. So let's count 1, 2, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ASCII pieces indexed by the index of 10 would return us this little r, which stands for the black rook, and respectively we'll have the values for all the other pieces. So let's try to make use of this sort of a stuff. And now we can reference our ASCII pieces by the encoded piece which we encounter on the board. So let's try to have a look at that. So okay, the problem is that we bring them as these ASCII characters as a decimals, as a decimal numbers, but we want to bring them as the characters. Okay, now this is it. Okay, so still something a bit wrong here. Oh, that's because I'm printing this commas. We don't need to print commas anymore, so let's drop the comma. Okay, now this looks absolutely fantastic. So you see, like, we get our piece set on the right and we got the set of empty squares on the left. But obviously we don't really need to print these empty squares, and I just wanted to show you how the board kind of looks like. But from now on we can get rid of this entire part on the right, because we need to keep track only of the board itself. So the main trick to do this using the hexadecimal 88 system. So we want print only on-board squares, or yeah, just we can say if square is on board, this, like, so we can say if, and now the expression. So we need to say that current given square bitwise ended with a hexadecimal 88. I'm not gonna be diving deep into explanation of how exactly it works and why it works. I would just like to show you how to make use of it, so how one can apply this while writing your own chess program. So if this oh my god, I don't remember, equals to 0, right? So if this expression equals to 0, it means that the square is on board. So we want to print our stuff only in case if this square is actually kind of on board. And you see, like, we dropped this right part, and there is a shortcut for expression like if the expression equals to 0. We can simply say, like, this exclamation mark is read as if not square bitwise ended by index, which means if you see this exclamation marks, this means that you try to match the case when the when the expression followed by this exclamation mark would return false. And this here we reference if it returns true, and here if it returns false. So this is kind of it. So absolutely the same result. And now, just to make it a little bit more readable, I would like to add some coordinates to this sort of a board. So first let's try to print our ranks. So I can say let's say print ranks, and we can say if, and so if we have our file equals to 0, so if file equals to 0, equals this, like in this case, I'm not sure if I need this curly braces or not. Well, I'll drop them if I don't need this. So if you have the only expression after the if statement, just like in JavaScript, you don't really need to specify these curly braces. You just can put this statement. That's kind of it. So if the file is equal to 0, well, let's first just to try to print out some random stuff here. So I don't know, let's say 1 followed by a couple of spaces. Save. So let's have a look. Okay, so we got our placeholder, and now instead of 1, obviously we want to print, well, some sort of a real rank. So I can say, so if I just put the rank directly, it would give me the ranks but within the wrong order. But and obviously the first rank is where the white pieces stand, not where the black pieces stand. So in order to reverse the order of this ranks, I need simply to say like 8 minus rank. So that's the way how one can calculate this. So now we got this prettified board. It's quite pretty nice. Ranks being referenced as well. Okay, and there is one more little thing here. So at the very end here we can actually print files, right? So yeah, obviously I don't really need this curly braces, so let me just try to get rid of them. Save, and here within the print files we can simply say like printf and a couple of spaces, I'm not sure how many, so A, B, C, D, E, F, G, H, and the new line, and it also would be nice to add a new line at the beginning. So let's have a look. Yeah, I need just to shift this to the right a slightly bit, so let's try this. Okay, perfect. So yeah, probably a couple of new lines would have been nice there as well. So yeah. And also, well, just to make it slightly prettier, I would like to print another, so printf another new line. So here we can say like just print indentation, just print new line. That's it. So just to make it slightly bit prettier like this. Also, I guess we can make this like and this like to have a little indentation from the left as well. So now it's absolutely readable. And the very last thing before we finish this video, so here you can see the standard, like world standard representation of the chessboard. When you're developing a chess engine, you see this uppercase letter stands for the white pieces, lowercase stand for the black pieces, and you have this pawn, rook, knight, bishop, queen, king. But obviously it's not really that easy, especially when you're debugging, when the position is getting complicated. It's not that cool to see how, so what this piece kind of mean there. So I just want to open my browser and try to find some Unicode chess pieces within the Wikipedia. So if I say Unicode chess pieces within the Wikipedia, so let's try to find some. Okay, so it seems to be the exact article here. So I'm not sure. No, this is not the Unicode. Oh, okay, so here they are. So I think I can just simply grab. So let me just see if I can use them directly. I think I can actually print save. So if I just can't use them directly, yeah, you see like this little white cane has been printed. So I can use them directly. Okay, and so we're starting with yeah. I just want to create a new variable, and I call this Unicode characters, and this would be equal to the string again. So the empty square would remain the same, and for all the other pieces, so starting from the white pawn, so I just grab the white pawn here and paste, and then I just grab the white knight and paste, and then I just grab the white bishop and paste, rook, paste, queen, paste, king, and paste, and then we go to the black pieces, so black pawn, paste, and then black knight, paste, black bishop, paste, black rook, paste, black queen, paste, black king, finally paste. And also, as far as we're not printing this off boards, that we can get rid of them here, and just let me just try to have a look. It still works, yeah. And also now we can replace this ASCII pieces with the Unicode ASCII pieces with the Unicode, not character but pieces, Unicode pieces. And I will provide 2 print lines optionally here, so like for Linux versus Windows. So just want to grab this one. I will just command this line out for a while, and here I will use this Unicode pieces. Okay, and just run this again. Okay, something has gone horribly wrong here. I just have no idea why this doesn't print. It should have print. Okay, just little hold on guys, hold on. Okay guys, sorry, just realized that the reason why this is happening, because I'm trying to print this character as a char, not but well, I have to do this as a string. But if I just try this directly, it will give me an error, because we need the format of the char pointer, not the char array. So we need just to slightly change this definition. It's not that easy as it might have seemed. So let me just try to initialize every single piece as the array element. So now it is considered not the array of characters but the array of strings, and that's the reason for using this additional pointer here. So this is the list of pointers, and every pointer is pointing to the Unicode character, which is treated to be like a string. So just to bear that in mind. And now it should work. I really hope so. Yeah, I didn't code in C for quite a bit of time, because my main specialty nowadays is web scraping and web development, and even have an entire channel related to those topics. Well, mostly web scraping, and you know, like, it's a bit tricky to switch from high-level Python to this low-level C coding. Okay, so I hold my breath and try to run this one more time, and it's almost working, but well, for some reason. So at least it does print some. It does print some pieces, but in a horribly wrong order. So okay, just let me debug this a little bit, and I'll get back with the solution pretty soon. Okay, so I just realized that the pawn is missing for some reason, and I'm just wondering, so where is the pawn missing there? I'm sorry. So the pawn should be right over in here, right? Okay. Okay, yeah, perfect. So finally we did manage to print this fancy Unicode characters in order to represent our chessboard. So from now on it would be way easier to print this sort of a pieces to screen. And again, if you, for some reason, if you can make use of this stuff, so maybe on Windows you don't know how to print the Unicode characters. Well, I don't, basically. So in this case, you just feel free to uncomment this line and command this line, and in that case you will get the standard sort of a worldwide standard representation of characters of chess pieces on the board using this ASCII characters. But again, I would be following this sort of stuff because it's more readable, and I really like these Unicode characters. Well, guys, so I guess this is it for this video. So a little bit of an announcement for the next one. So obviously chessboard is not only about the pieces, it also needs to keep track of the side to move, the in peasant square, and the castling rights. And all that sort of an information is actually located within what is known as FEN string, which is the way to store the chessboard position in a single string. But again, this would be covered in the next video. So in the next video we're gonna write the function that would be parsing the FEN string. So the matter of setting up the chessboard position on our board would be the matter of just pasting in the only string as an argument to the parse FEN function, and later on we would be able to easily print that position like using this print board function. And also we'll add some functionality to the print board function, so it would be able to keep track of the side to move, the in peasant square, and the castling rights as well. Well, now this is definitely it for this video. So I hope you learned something interesting out of this tutorial. So see you next video, guys. Until then, and take care.